All right, happy Saturday. Woohoo! And there was much rejoicing as always. All right, so welcome to our first discussion on materials. Today we're going to be working on the reflectivity portion of the Pixar surface. That's probably the biggest one to tackle. And then on Tuesday, we're going to tackle transparency, transmission, glass, basically. So if you haven't done so, download the Lecture5 demo files. That'll give us simple scene, a couple of objects that we can experiment with. Download the Project 5 bread and thermos reference. And today starts the day where you take Project 4 and roll that over into Project 5. All right, workflow for doing that, take your whole project folder, duplicate it, rename it. This way you always have Project 4 to fall back on should Project 5 crap out with Maya. But that would never happen, right?
No. Nope.
Never. It's software. What could go wrong?
Maya's totally perfect. In every aspect of the word.
Like us all, it is. Totally perfect. So, Project 4, if you haven't done so, take a look at the notes from the grading for Project 4, because you will need to address some of those light issues, if there are any, so that Project 5 displays properly. Because good lighting is only going to help you when you start adding textures and materials. And actually, it's materials first, then textures. So next week, Discord and office hours on Wednesdays and Fridays, 10 to 4 basically. Office hours are 10 to 12 and then 2 to 4. Don't forget, optional go to training lab from 1 to 5 on Fridays. Room schedule next week. We are back in 112 for Tuesday and Thursday. And then we are back here until the rest of the month. This will be our home at the end of the month. So Saturday, and these are normal times. We don't run into any issues until week 4, where we have some late starts. Week 4 on Tuesday and Thursday, we have a 5 p.m. start. So lecture 5 to 9, and then lab will be 9 to 1. Yes. Lovely. Yeah. This should be in your schedule too. On Connect.
Yeah, it's always easier to have it just in case in your phone.
Yeah, no, I don't blame you. Of course, if you are using Go to Training, you could just take a screenshot and bypass the need to use your phone. But that's just me. What's that?
It's easy to dig into my phone.
Okay. All right, so today, reflectivity, basically it's primary specularity. That's where we're going to be doing all the work. Primary specular part of the material, which is right under diffuse. We're going to be dealing with reflections, reflectivity, and roughness. Roughness is going to basically drive. Hey, come around the side.
David. Okay.
Yeah. Like he ran.
There he is.
We're also going to be talking about anisotropy, which is brushed metal, basically. It's the easiest way to understand it. And also BRDF. If you remember from the first day of rendering, we were always talking about BXDF in the render settings. Today we are defining the X factor, and that is R for reflectivity.
Sorry.
You know how to make an entrance. Huh? So, BXDF. X is now R, so we're talking about bidirectional reflectance distribution function. That R is going to be how our material calculates light in 2 different directions. For anybody keeping score, for gamers, your PBR material, it uses BRDF also. That's why metallic materials look so much better in the last 5 years. And research discussion will be due Wednesday, next Wednesday, the 15th, in addition to your Project 5 and the material discussion. Any questions? Nope. All right. So I'm going to go over the research discussion a little bit because there's always some haziness on this part. I want to try and make it as clear as possible. If you go into the Lesson 5 discussion, I think it's 5.2 is the research discussion. You'll find all the criteria in there and the instructions. From what I understand, you have all used the EBSCO database at some point. Research database online. Okay, if you haven't, you will, hopefully. EBSCO database is basically a nationwide network of universities, education, and research facilities that pool resources together, that share information. It's kind of like having a huge library system online that you can check stuff out. And since Full Sail is a member, that means that we have access to a lot of articles, whether they're research articles, whether they're entertainment articles, about all kinds of different topics. This is not just related to CG or 3D. This is related to anything educational. Even to the newest stuff that is out there that has not actually been created yet, but have what we call white papers associated with them. White papers are usually very formal research papers that have a very specific format. They are peer-reviewed to basically put the information that the research people, usually it's more than one person doing these papers, the research group put together and they're sharing. And then a whole bunch of people get together and they review it for accuracy. They take a look at the viability of it and they make comments on it. All right. We don't have to get anything that formal for us, although you can if you want to. But basically, you guys are going to look for articles to write about what drives you, what brought you to Full Sail, what is your passion. Doesn't have to be shading and lighting specific. But why are you here? What motivates you? Other than student loans and bills and you have to get up and go. What motivates you creatively?
So avoid the cliches.
Yes. So what motivates you creatively? And it's a good chance for you to share that passion with other people. And that's really what I want this to be about. I want this to be about you-centric, which means how does it relate to you personally? How does it affect you? Why do you think it's relevant? Why do you think it's pertinent? Why did you read the article? If it was a good article, great. You can relate to that. If it was a bad article, fine. That's good too. Because it's always good to know what's out there. The whole idea of using something reliable like EBSCO or a couple of other resources that I have is that they are not just a blog with somebody's opinion. And that's the danger of blogs. Unless blogs are written in a very specific way with people that are knowledgeable in the industry, not just because they're trolling somebody or they're trash talking a topic or a film or anything or a game. Don't care about that. We want to have information that is accurate, reliable, can be backed up with facts and other information. All right, so in addition to EBSCO and that entire database system that's there, you also have a couple of online journals that are acceptable. One is Gamasutra. For all you gamers out there, this is a really big site. If you're not familiar with it, get to know it. The other is the International Journal of Game Studies. And basically, this is a lot more formal. It's a lot more research-oriented. But again, it's a reliable source. So, International Journal of Game Studies, Game Research. You can use that. You can use Gama Sutra. If you find something that you think is reliable, that you think can work, and it's not on out of either EBSCO or Gama Sutra or Game Studies, send me the link, I'll look at it. I'll give you a thumbs up or thumbs down for it. I'm just looking to make sure that the information that you're going to read is written by a reliable source. Somebody who's been in the industry, who knows what they're doing, who either did research on it, who worked in the industry, or who has written articles enough in the industry where they know trends, they know what's going on reliably. That's the big key factor.
Can it be like a GDC video, or we can't use those?
It can be a video, but it needs to have some written information with it.
Oh,
Because a video is all fine and well, but that's usually just high-level topic of some kind of research that's been done. People usually present findings, or they will talk about new projects that are going on. So that can be supplemental, but not primary. All right, so when you find your article, if you go through EBSCO, the beauty of EBSCO is that they give you a lot of functionality right up front. One of them is citation, which you will need to have a citation in this article. What kind of citation format does Full Sail use? APA, yep, American Psychological Association. Why? Because out of all the formats, they chose that one, and it's a pretty common format. I know UCF uses it, a couple other institutions around use that also. It's a very common format. It's very specific about author, title, journal it's from, pages it's on, just very important high-level information. But it's got to be specific. If you choose to do something out of Gama Sutra or Game Studies, you need to create your own citation. And it needs to follow the same format. So, in your research discussion, it's going to be citation first, the permalink, which if you're in EBSCO, you need to click the permalink button. That will give you a highlighted URL that you can then copy and paste. That is different than the URL that you click on to get to the article, because in EBSCO, if you just copy the URL out of the top, the web address, and paste it in, that is only going to function for your login at your specific time in EBSCO. That's not the permalink. Permalink means that you can send it to anybody, whether they're logged into EBSCO or not, whether they're in network, out of network, they can get to that article. And that's what I need, is the permalink. So, citation, permalink, article that you're going to write about. And again, you-centric. Why you chose that article, why you found it motivating, why you found it relevant, anything else that you can relate to you. Yes?
So this can be written in first person?
Yeah, for the most part, yeah.
Okay.
Because I don't want a synopsis of the article. I mean, you're going to send me a link, I'm going to look at the article, and if I haven't read it, sometimes I read it. So, what I want, though, is how that related to you and why you wanted to share it with other people.
Okay.
And that's really what it comes down to. Now, if you are using Gama Sutra or Game Studies, you can copy the URL or the web address right out of your browser because you're not going through EBSCO. That makes sense. But only if you're doing Game Studies or Gama Sutra. You're in EBSCO, use the permalink. I'll either get a full HTML link or I'll get a full PDF link. All right, so this is all due Wednesday. So here are a couple examples. This one, the permalink was not used. So consequently, the session is closed as soon as you go out of it. This one, they found an article, but It wasn't a full article. It happened to be an abstract, which is usually part of a formal paper. An abstract, anybody know what it is? Yeah, just a brief summary. It's a couple paragraphs, sometimes very wordy. It could be 4, 5, 6 paragraphs. It looks like the article, but usually the article is way longer and really technical. So, abstract, no, that doesn't work. It's not an article. Correct. So I have citation, I have the link, I've got the article or your research discussion under it. In this case, it took me to a PDF. Doesn't matter what it is, whether it's PDF or HTML. All right, so look over the instructions for it. If you have any questions, let me know. All right, any questions off the top of anybody's head? Anything you can think of? Yeah.
Where can we find the EBSCO site? Is it on Full Sail?
There's instructions on the.
Okay.
That's on
Okay.
You can get to it from Connect.
Okay.
If you go into the library, go to online, and then in there are online research databases. Any others? Okay, let's talk about materials. Again, today we are talking about reflectivity. So, at the very beginning, when we first started talking about the Pixar surface and the diffuse part of the material, we came across this. Why do we see red?
Because that's the only light that's reflected or red light.
Right. Most of the other light rays are what? What happens?
Absorbed.
They're absorbed, right. Now, we see reflections here, obviously, because we know it's a red object. We see it reflected. The reason that it looks like this is because when light rays hit it, they hit a surface with an irregular surface. Let me see if I can zoom out just a little. Well, I guess zoom doesn't work. All right, let's see. There we go. So there's our surface on the right here. You can see it has irregular features on it. Light rays come in, especially if they are direct light rays. They usually come in parallel to each other. And then they hit this kind of surface and they bounce back in all different directions. So the light across that surface diffuses or spreads out. Now, we get into a smoother surface. We get more organized light rays that bounce off of it. So organized light rays coming in, they hit the surface, they bounce back. We talked a little bit about this, but every time that we measure how something bounces or reflects, we usually reference it to the angle of the surface, to the angle of the camera, and then the normals on the surface itself. You guys know what surface normals are, right? What are they? Yeah.
It's the line that runs parallel to the surface, right?
No, it's
Not-
a texture mat that looks like it has something on it, and so the light interacts with it, even though it's flat.
Yes.
Basically, it's also referred to as a height mat, which makes the texture appear to actually have bumps and ridges, even though it's completely flat.
You're close, but no, a surface normal is specific to each polygon that you have. Surface, yeah, go ahead.
How the surface normally is, like in mine.
Well, it actually refers, and here's the thing about surface normals. They are always perpendicular to whatever direction the surface is. So if you have a curved surface, like my a cylindrical surface, like my water bottle here, if the normal is facing right at the camera, you will get light rays, if it hits it, that will bounce right back to the camera. Now, as the surface normal turns away from the camera, it measures things differently. So, when a surface normal is looking directly at the camera, we see one type of reflection. When the surface normal is 90 degrees from the camera, we see another type of reflection. And this goes for real-world objects and even CG objects at the same time. Now, when we build normals, they always tell the surface where it is in relation to the camera. So, again, if my normal is pointed right at you, the camera, you're going to say, oh, okay, that's 0 degree reflection. Any degree off, then you're going to see something a little bit different. Why is that important to us? Because that's how we measure how light rays bounce in CG. We always measure the angle that light hits that surface based on the angle of the normal to the surface. So, up here in my example, right, surface, on the right, it's smooth, it's a mirror-like surface. Here's my surface normal. I have a light ray coming in, roughly about 45 degrees. It hits the surface. The surface has no irregularities on it, relatively smooth. It will then bounce back in the opposite direction. Angle of incidence is the ray coming in. The angle of reflectance is the ray going out. Everything we do in CG is based off of that. Now, you're all correct about height maps and stuff like that because they are all measured based on where the normals are to where the camera is. Does that make sense? And when we get into maps, we're going to talk about what makes them do that. But for now, we're just talking about how the surface normal measures the angle of a ray hitting it. And everything's all about an angle and a relationship. Right, so when we talk about reflectivity, when we get these organized rays in, if you have organized patterns, you will get organized information back. So, imagine that there's not just one ray hitting the surface, but there are thousands of them. They're going to hit that surface, they're going to bounce back roughly in an organized fashion if the surface is smooth. What does that mean for us? Well, instead of us getting this, where everything's scattered, we get organized information so we can actually start to see some environment reflections in our materials. Another feature of this relationship between the angle of the surface and the angle of the normal, the angle of the camera, the angle of the light, is these direct light highlights called speck highlights. So, this is when the light finds the camera directly. Now, if you remember, we talked about, or we watched that Disney video where they talked about path tracing, right? The rays shot out from the camera, they hit objects, and what they're trying to do is once they bounce off an object to find the light source. All right, so what happens is when we see reflectivity, so for example, the front of my phone, that's a pretty smooth surface. You can pretty much see it. Can everybody see the light in it from the projector? All right, so when that actually shines in your eyes, that means that that light ray has hit my surface, which is the front of my phone, and traveled directly to you. We see that highlight right here. So this is indirect information. And this would be the direct information. This is directly from a light itself. Now, that reflection, that shape, that speck highlight will take on the shape of whatever the light source is. If it's square, it'll be square. If it's round, like our little projector, it'll be round. If it's a window, it'll take on the shape of the window. Does that make sense? Questions? All right, so technically, basic reflective materials are called isotropic reflections. That means they're a product of three components. One is the base. That's your diffuse. That's always going to be your base color. That gives us an idea of what the material is as far as a foundation goes. Actual reflectivity, we add all this information in. So it's base plus reflected environment plus specular direct light highlights. Those three together give us a final reflective surface. Like I said, if we do not have a visible direct light source, you won't see a highlight, a speck highlight, but you will see reflectivity in it. Everybody have their charger? Chargers are relatively reflective. If you take a look, you can see a little bit of the environment in it. If you hold it under a light, you should see a speck highlight. All right, does that make sense? All right, so I usually like to use my mouse. I think I mentioned this before. Because this contains three different types of reflective materials on it. Most mice do. They'll usually have a nice smooth part, like the back of my mouse, which you can see right here on the slide. This was taken at my desk, so the light source above my desk is one of those big rectangular desk lights. It's a fluorescent above my desk, right? When I hold my mouse up here, you can see that the highlight is round because the projector's acting like a spotlight. So it's a round light source. You can see it's nice, it's perfectly round, it's nice and sharp. If you got close enough, you could see reflections in the back of this. Just like you can back here, right here. You can see some environment. You see my screen, you see my messy wall, you see all kinds of stuff there. This type of surface we would describe as very low rough, very low amount of roughness in it. It's reflective, it's smooth, it's hard, sharp details in the reflections. Now, same light source, same mouse. All I have to do is just kind of rotate my mouse so that now the light source hits the top. So here in the room, you can see my round light source real nice here. What happens to it when it hits the top part of my buttons?
The light is more diffused and it's slightly more rough. You can still see the specular highlight on it, but you can't define environments or you can't define the light as well as you did with the other side.
Right, exactly. Like you said, the surface is rougher, so it takes all the light rays coming in, diffuses it. Now, it's not diffused as much as a surface like, say, the carpet, because the carpet has thousands of fibers in it. All those fibers, have light rays that bounce off of them. They're all uneven. They're all spread apart. They just diffuse everything. All right, so this would be considered, this top part of my mouse where the buttons are, that would be considered a medium to medium-high roughness surface. It's rough. You can still see the speck highlight in it, but it's spread out. If you can see any reflections in there, they're going to be really what we call soft and blurry. In a technical sense, we would call this a low glossy surface. The other one, the hard smooth part, that would be a high glossy surface. Now, most mice also have a third part, which is usually kind of a non-slip rubber grip on the sides. So, low roughness, high gloss, medium to high roughness, medium gloss, and on the sides. You can still see a little bit, but what happens to it?
More and more diffuse.
Yeah, it gets diffused even more. Still has a what we call a sheen to it because you can still see the light on there, but it's just so spread out. It's hard to tell what the shape of the light is. It's hard to tell. You're definitely not going to be able to see any environment reflections in there. You might see some vague color, different shapes. Like in our room here, we've got orange walls or yellowish walls on the sides. We have a green wall in the back and a white wall in the front. We might be able to make out vague color changes, but that's about it. So this would be a very high roughness level of surface. Very blurry reflections, really very low glossy surface. Really soft, really blurry highlights. All right, so somebody give me an example in this room, either on you or in this room, of a very smooth, glossy surface.
Phones.
Phones, exactly.
The
Yep,
plastic
perfect.
on these.
Perfect, yep. Plastic on these, usually. Depends on how clean it is, of course.
Yeah.
I'm looking at mine and thinking, yeah.
No.
But you can still see it.
Your,
Use glasses, maybe?
Yep. Glasses?
Specifically yours.
Specifically.
Specifically mine, nobody else.
Yeah, that's true. Oh, yeah.
Just
Not as much as mine.
what about the
your computer screens.
Computer screens, the front of them?
Yeah. I mean,
Now, it depends on whether they've got an anti-glare film on them or not.
yeah.
Because basically that kind of diffuses it a little bit, not when you look at it directly, but when you look at it at an angle.
Yeah. What about the inside of the
Okay. Apple logo,
keyboard
Oh
eyes.
yeah, those
pretty much, yeah.
the inside of the lamps. I'm assuming. Not these lamps, like those, because they're actually shooting the light out.
Okay, so those little ceiling lamps with the little hoods on them
Yeah.
in the back. Okay.
The exit sign?
Exit sign. Yeah. That is pretty reflective. You can see the ceiling on it.
The clock.
Clock. Yep. Now, the face of the clock, I would say yes. The body, no. And we'll get into why in a second with the body, because that leads us into brushed metal and anisotropic materials. What's that?
Would it be considered medium?
The clock,
The body.
the body. Probably, yeah. Yep, medium. Medium, maybe medium high. Bottles? Plastic bottles, usually. How about the metal on some of the chairs? Some of them have kind of nickel, others are painted black. Depends on what kind of chair you have. All right, how about medium gloss? Kind of like the buttons on the top of your mouse, or at least my mouse anyway.
The surface.
The
The surface of your keyboard. Or the surface of your computer right here.
Okay, it depends. Yeah, see, you don't have a Mac, you've got, what is it, a Lenovo? So yours is probably along the same lines as your
Yeah.
tablet. The Macs,
What about the pads for the?
okay, the pads, definitely, that's a lot shinier than the rest of
like
it.
opposite.
Or well, I mean, if you want like a technical about it, if you notice my tablet
it's
has
rough?
it's roughed out here, but then at the middle. it's
But
got-
where you've worn it
Yeah.
smooth, that's, yep, that would be good.
It's sweet.
How about the tabletops?
Oh, I was gonna say, what about fingernails?
Well, it depends.
very rough, the tables, you can see the highlight from that.
So you can see that.
Depends on the angle you're looking at it from. If you put your head down, you can start to see more reflectivity on it than if you look at it straight on.
What about
About this,
that thing?
plastic on the headphones.
This, the whiteboard,
No, what's it called, with a projector? Projector.
the screen.
Yeah, the screen.
The screen, that's going to be really pretty diffuse. Because if it were really reflective, you would have too much glare on it. So it's got like silver nitrate flakes in it. If you come up and look at it, you can see it kind of shimmers. It's meant to be reflective, but diffuse at the same time. At least when you look at it.
What about leather, or that plastic on that chair, that blue?
Okay, plastic on the chair.
Blackboard?
Yep. Whiteboard.
Look at whiteboard.
No chalk here.
Thank God.
Yes.
Fingernails?
Fingernails, yeah, you mentioned that before. The pen, yep. Now, if you got your nails painted, that's a whole other thing. Then you've got a coat of smooth on top of it. But normally, fingernails are usually pretty rough. All right, how about super, very low rough?
Mouse pad.
The keyboard,
Keyboard?
the yellow one,
Okay.
at least from the back of it.
Yeah, that's pretty rough.
Any cloth or carpet or your hair maybe?
Oh, that's very.
That's going to be like totally diffused. At least
Hair.
most of the time.
Hair would
The-
be, I think hair would be medium.
Hair depends actually on the people.
Yeah, it depends. If it's really short, it's going to be
You put something in there.
diffuse.
And also if you got, there are some people that have really glossy long hair. So.
Yes, well, it depends on the oil content of your hair, just like the oil content of your skin.
Yeah.
So it depends on, skin can look different in a lot of different situations.
The,
What were you gonna say? The back?
casing of the laptop.
Yep, back. That's your brushed aluminum for those of you that don't have it covered.
And our covered sticker.
Yes. Hiding on everything you know. All right, good, good. How about the walls?
Yeah.
Yeah.
Yeah, what?
I mean, I see that.
They are walls. I
They are walls. They are walls, definitely.
Okay.
Sure that.
Because the light actually does reflect off of it if the light is.
Is it diffuse completely
No.
or?
It's mostly diffused because I do not see a highlight or a specular on the wall.
If
At
you
least
look up at the top, like where the beam has a high intensity on it, you can see the specular
But it's
highlight.
also the angle of the light too, because it's not just directly on it, it's like being down. You could see the highlight if you had it like straight on.
I mean, I can see the highlight from where I'm sitting.
Sound one.
How about the foam here?
completely diffused. Is it? Yeah.
There's,
Sparkles.
it's sparkles, so I feel like. that's
Sparkles, just like the screen. We'll name it Sparkles.
I feel like that's a.
Aw.
It's like sand. You
It's
know,
a trick.
Little bit, yeah.
when you look
Yeah.
at sand, sand has some bits that do
Well,
shine
that's
more.
because you have a lot of grain, very minuscule, very small,
All
and
the
some
silicone in it.
faces are very smooth and some are very rough.
Just like in the.
Just like this.
Yeah, some of them, the ones that happen to be smooth, or some of them that are smooth happen to, be on the right angle and the reflection hits our eyes.
Yep. Okay, good.
I need to get-
Let me turn the lights on, and then we can actually get a
Close your
better
eyes.
idea
Ah,
of what
That's
everything
okay.
looks
I
like.
feel better.
the light burns.
It burns us, yes, I know, burns the precious.
Where it's good for it.
All right, so tabletops, any different now that there's a little more light on them?
There's less specular.
Less specular, right? How about the kind of like leather armrests here?
Yeah.
Well, how do they relate to the top of the surface? Are they the same?
No,
No.
No.
Which one is rougher?
the leather one.
The rubber stuff.
Okay, good. How about chairs? Most of them.
The,
Depends on which chair it is. This one is going to be different than most of the other chairs.
the handles,
Because
the
they're not.
armrests.
So these were probably much rougher, but then all those elbows rubbing on them after so many classes, it's gonna smooth out.
A little bit of elbow grease, you know?
You think of
Ooh,
it,
and I
sure.
touched it. Ooh.
Really?
All right. How about the cushion?
Shame.
That's
The
very-
cushion is,
Isn't that like very high
it's super
roughness?
diffuse. So it's high.
Is it like the carpet?
Yes.
So what? Kinda,
Kind of.
Yeah.
you can see.
But if we change the angle, it's huge. Ooh, then you highlight all the stains and nasty unidentified things on it. Yeah.
Just little lines and everything.
How about our dolly?
It is.
Yellow paint. It's got some areas that are chipped away. It's got some dirt on it.
All the
What
diseases
about
on
the,
it.
the wire that's on it, the extension cord?
Yep, extension cord, that's a whole other, that could be like a whole study in just materials right there.
Right in this class.
Because we know generally what's under it, if you clean this up, it's probably gonna be smoother plastic, but this is really roughed up.
Well used.
Yep, well used, consequently, it's got all kinds of paint,
Rubber,
rubber,
dust,
What?
dirt,
yep,
Paint.
dust, dirt.
probably.
Well, let's go to the metal part though.
Plus.
Pretty much.
What's that?
That's only this now, it's gonna be germaphobics.
Yep, exactly.
Too late, I'm already there.
Alright, so the metal.
Paper.
It is
Diffuse,
very specular, like it's very reflective.
Okay, is it enough where you can see your face if you come up to it?
If it was bigger and I came up to
Come on up
it,
and look.
Yes.
I can see the light highlight from here.
The answer is no, by the way.
Stand corrected.
Yeah.
You can see the reflection.
Okay, what kind of detail can you see? Would you
I can
label
see
it
the
like
fact that my
higher
hands are-
roughness than you thought initially?
Yes, higher reference, definitely.
Yeah, but you can definitely see the spec highlight.
you can see the shape of the light source as well. I can see that the lights are little squares.
So, depending on your angle,
Yeah.
depending on how you look at it, up those little round circles from the overhead lights or from the square or rectangular reflection, fluorescence change shape when you look at it different angles. All right, good, good. How about speakers?
Depends on.
This
where-
one.
Depends on where you're looking.
Depends on the area actually, because it has a lot of
Medium to
different
high.
This is rubbery.
Sticky.
This is rubbery.
Oh,
as I
I'm gonna be a
wet my
germaphobe by the
hand.
end of the day.
Yeah. This
I said before.
That's a new one.
Porous.
looks porous, but it's not. It's carbon fiber, very smooth.
I can make an armor out of that. Armor. Armor, no. Carbon fiber.
What about doors?
Is it
The
glossy?
wood.
The wood is,
High,
High what?
Diffuse.
roughness.
Okay, high roughness.
I mean,
Can you see any speck highlighted, any reflection?
I can see a reflection. It's not very detailed, but when you
It's
were
a very
close to the
faint
door,
reflection.
you can see like the shape of your body,
Mhm.
like reflecting in the door.
Yep.
Probably with a different light.
And how polished it is.
and it depends on how
It's
much.
pretty smooth, but it's got a coating on it, but you can definitely feel roughness on it.
Mm.
It's not glassy rough. That's why the details are not as sharp.
How would you tell the difference between an object like a metal that is truly reflective as opposed to, let's say, a ball of like, you know, a stone ball that I just put a coat of reflective material
Depends on how much light gets through the coating on it and gets to the material.
Hmm.
Most of
So-
the time, we recognize metal based on the way it reflects back to us. Most of the time, metal will have the reflections that you can see be based on the color of the metal itself.
Right.
Whereas most plastic objects, most other objects will have more environment color in it than it will surface color.
There's also a way to polish stone to give it like an almost
Marble.
mirror-like reflective structure. No, any stone, like people have done it with granite.
Just take an example.
Oh, I'm sorry, I thought you
So-
were good,
so if
more
I-
period.
If I were to hold let's say a stone ball that is painted like a, it's painted yellow and then I put a coat of like glossy polish on it, like nail polish.
Okay.
And then I have a ball of gold of the same yellow. What would the difference be when I both of them?
Like I said, it depends on how much light can get through your coating.
Please no.
There we go. Mischief managed. There we go.
I got that reference.
Watching Harry Potter
It's like that
yesterday.
scene from Signs, it's like there's two of them talking.
Yes. So it depends on how much light can get through your
Mm.
material to the actual metal part.
Mm.
If you've got them coated the same way, you might not be able to tell.
Right.
Depends on how thick the coat is and what you have on top of that.
Also, if I had if I had the rock, would have the reflections will be more like white, per se, as opposed to
It
the gold.
depends on, it depends on a couple of things. We're gonna get into that when we talk about reflectivity more.
Mm.
But, good example is, and I'll start this, let's see.
Because from what I've seen on like paintings and like stuff like that, the way people study paintings a lot.
Oh, good, okay, I do have one of these.
Is
All
that,
right,
when something is wet, the highlight tends to be very pale.
Right.
Very white. But when something is like golden color, the highlight is like yellow, and that's what gives it
that's
that.
what I'm gonna get to right
Yeah,
now.
okay, sorry.
So what color would you say the bottle body is here?
Grayish.
Grayish, silverish? Okay. How about this?
Same, the silver.
Oh, it's
This is my coffee mug, same. How about this little, it's kind of like a little screwdriver on the end of my key?
Silver.
Silvery. How about this?
Is it like yellowish?
It's kind
Like a
of
coin.
grayish.
It's a,
Like a brass color.
Yeah.
Yeah.
Yeah, brass color, yellowish. It's gonna be kinda hard to see. I'm trying to make sure I angle it and dangle it so you guys can get an idea of it. All right, so if this is yellowish brassy material, this is what we call red metal.
Mm.
This is what we call white metal.
Third time's a charm.
Right?
Right, so I'll leave it running so we can find the culprit and then silence them forever.
Kick them out. Failed for everything.
Okay, so red metal, this is what we call white metal.
Mm.
The reason it is because white metal, this will reflect all of the spectrums of light relatively evenly. Remember, whenever you have all the bands of light together on top of each other, you get white. When you have anything that's brass, copper, gold, what's another one? Brass, copper, gold, bronze. Yep, bronze. Those are your red metals. Why? Because they primarily reflect the reddish spectrum of light color.
Mm.
So that's what makes gold look like gold, brass look like brass, bronze look like bronze.
So if I were to like, look at my reflection on something that is silver, I will be able to make out, the colors of my face. But if I
Right, well,
were-
it would be neutral. It would
Yeah.
be whitish because it's a white metal, silver.
And if I do it on gold, I will see everything as if I was seeing it through like a filter.
Yes,
Gold.
you would see more of gold being reflected back to you. And that's why most metals tend to do that. Depending on the purity of the metal, how it's polished. So actually I have a PDF if anybody's interested in Project 5 down here under reading. It's called Why Copper is Reddish in Color. It's kind of scientific, but the front page is easy enough to understand. It basically just kind of says what I just told you guys. But it's interesting to read.
What about like darker metals, like, I'm trying to think of, you know, like those metal brushes you use to like blend things, they're almost like gray or darker, almost black. What about those?
Well, if you're talking about a wire brush,
Yeah.
remember there's a whole bunch of fibers for one thing, so you're seeing shadow. You're also seeing a lot of, if it's not polished and it's not smooth, you're going to see a lot of diffuse material or a lot of diffused lighting in there. And also, it may absorb more of the light rays than a more polished like silver or like platinum or one of those colors. So consequently, you're going to get a darker value back.
Okay.
It's still going to be whitish, but it's going to be a lot more absorbent than reflectant. Yes?
Is that the one time remote development reference defined? The PDF?
No. It's right here. Right under reading, Project 5.
Okay.
There's Chapter 9 ray tracing. There's the Pixar surface. This is basically takes you to Pixar's website. There's the refractive index, which we're going to get to. That is gold, by the way. That will be something you'll probably want to keep bookmarked for as long as you're in CG. All right, so does that make sense so far? Any questions? Okay. One thing about the material, the Pixar surface, which most major, what we call advanced materials do, is something called conservation of energy. What they do is they only allow you to have 100% of the energy at any one time in any part of the material. Until today, all of our energy has been in the diffuse part of the material. All right, so all the energy's been in the diffuse part of the material. Once we add reflectivity in, we are starting to siphon some of that energy off of the diffuse part of the material. How reflective the material is going to be determined by how much environment reflections you see, whether they are sharp, whether they're rough, and how much specular highlight you see, whether it's sharp or whether it's rough. But in the end, the equation always comes out to be the same. Diffuse plus reflections plus refractions or transmission, transparency, all come up to be 100%. If something is completely reflective, all the energy is in the reflective portion of the material. There is no diffuse in it at all. That's why when we get into making metals, everything we see here about my bottle, because it's made of brushed metal, everything we see here is about reflectivity. So when we start making metal materials, we have virtually no diffuse in them at all. So just kind of keep this in mind. We're going to hammer it again next lecture when we talk about transmission and refraction. All right, in the Pixar surface, they have two different kinds of modes that you can use to create reflectivity. One is called artistic, which you get by default, and the other is called physical. Now, the artistic mode is broken down into easy things that artists can understand. You've got a face color when you look directly at something, and you've got an edge color when it's more of a 90-degree angle. And then we have this thing called a Fresnel exponent, which basically just blends the face and the edge colors together. Now, when we say color, we're really talking about reflectivity. Because 99% of the time, we are not going to plug anything into our face color or edge color. They're all going to get color based on the environment. Questions? Does that make sense so far? So, artistic, face color, edge color, those are the two things you worry about the most.
Where do you find these nodes, like the attributes? Just on the pixel surface?
Pixar surface, it's primary specular, which is right under diffuse. And that's what we're going to be talking about. Now, there is just to clarify this, there is a roughness specular model too, which makes no sense because you can do everything in the roughness that you can do in the primary specular. I have no idea why there's two of them. You can only make something so rough before it's either totally diffuse or it's totally a mirror. All right, there we go. So let's create a Pixar surface material. So under diffuse, and diffuse also has advanced under it. Right under there is primary specular. So there's rough specular, which we're not even going to talk about because everything you can do in rough specular you can do up here. It's way too confusing. But primary specular. Right underneath the heading, you'll see specular Fresnel mode. By default, it is set to artistic. Artistic gives you a lost connection. So artistic gives you a restored connection. Artistic has face color, edge color. Those are the two things you worry about. And a Fresnel exponent. That blends those two together. It'll make more sense when we actually deal with why we talk about face color, edge color. And then there's roughness. If I change the mode from artistic to physical, it changes the attribute under there. So instead of getting face color, edge color, I just get edge color, I get refraction index, and I get this thing called an extinction coefficient.
Are we going to be using both, or are you going to have us do artistic for the most part? Oh.
This is how we break it down. You're right on track. This is how we break it down. How do you know which one to use? And the terminology. All right, so I use the blue color coding for artistic, the red color coding for physical. Just to try and keep it straight. All right, so artistic are things that we consider technically dielectric materials. They are poor conductors of energy. Anybody here familiar with electronics?
Yeah.
Okay, they would be your insulators, things that don't conduct the energy or electricity very well. They conduct it to some degree, but you could not really run a current or run anything off of them. Things like paper, porcelain, glass, steel. Well, no, steel would be metal, sorry. Glass, plastics, air, rubber, wood, like I mentioned, concrete, fabric, carpet, rubber. Got that in there. Conductors, things like steel, copper, aluminum, iron, gold, silver, brass, bronze. Those are conductors. they conduct electricity, they are metals. We're going to use the physical mode for metals. We're going to use the artistic mode for pretty much everything that's not metal. Why? Because when we start dealing with metals, metals technically are measured differently than normal reflectant objects. So let's talk about artistic first, because then when we get into metal, it'll kind of make more sense. Face color, like I said, this is really 0 to 1, 0 being black, 1 being white. It's called specular color because, yes, technically you can put a color in it, but we don't. We use it to measure reflectivity. So, face color, 0 degree, looking straight at the camera. Edge color, 90 degrees from where you're viewing. Those are your bidirectional measurements. Give you an example of how things can change based on the angle you look at it. Everybody here has been down either to the beach or lake or stream, a river,
Not
right?
recently.
Not you?
Not recently.
Well, yesterday. Oh, yesterday.
So imagine as a kid, you're barefoot, you go down to the beach, the water runs up, you look through the water, you can see your feet at the bottom. Okay, as you pick your head up, this looking directly at your feet, you're 0 degree. You're looking straight through the water. Perfect viewing angle. As you pick your head up, all of a sudden the bottom starts to get darker and darker and darker. And by the time your head is up almost at the horizon, can you see through the water at all?
Yeah.
What do you see when you're looking at the horizon on a body of water? Sky reflections, blue. That is a Fresnel reflection. Because you're looking at it 0 degree, it's transparent. When you pick your head up and look at it 90 degrees, it becomes almost totally reflective. Most objects exhibit a high degree of reflectivity at a 90 degree angle. Anybody ever driven down a long road in front of the car? It looks totally, normal asphalt.
Yep.
You look out into the distance toward the horizon, it starts to look wet.
Yep.
That
Wet is an illusion. That's basically, you're kind of at a 90 degree viewing angle, you're seeing nothing but reflectivity from the sky.
is this how rim light is made as well?
Well, rim light is man-made, for one thing. It's meant to pick up on that feature. And we use it as an artistic tool to separate objects from each other. But that's kind of the phenomenon why we use rim light and why it looks effective. Does that make sense so far? Questions? Right, so face color, 0 degree, edge color, 90 degree reflectivity. The Fresnel exponent, how far does the 0 degree reflection, how far does that strength go before it gets to 90 degrees, before it drops off and the 90 degree picks up? Most of the time we see a lot of reflectivity on the edges, but it doesn't stay very reflective long on those edges. When we start making materials, it'll make a lot more sense because we can actually break these down separately. We can look at just edge color, we can look at just face color and see what the two look like. Yes?
What is, I guess, exactly the glancing angle, like?
Glancing angle is when you look at something, come on up. Okay, so stand right about here and look at the speaker. Okay, so you see how reflective it is up here. So come up closer and try to look at it at more of a, it's not quite as reflective.
Okay.
So most objects exhibit a lot of reflectivity. Now on the body itself where it's less smooth, you're going to see a lot of reflectivity here, but it's going to hold up maybe 1 or 2 degrees. It's not going to be much past like 88 degrees. You're just seeing a little bit of sheen on the edge, and that's it. And that's really what this whole Fresnel exponent does, is how far do you have to change your viewing angle before this either kicks in or kicks off?
Okay.
And your 0 degree, when you look at something directly, how far does that stay before it turns into a 90 degree? Where it becomes either more reflective, or in the case of metal, metal's almost the opposite, less reflective on the edges. Anybody else want to come up and see? Like I said, water is the perfect example. If you go down to the ocean, you go down to a stream, you know, a highway, a long highway on a hot day is a good way to look at it also. So this Fresnel exponent, most of the time we don't even have to worry about it, because the default that they have there is the average kind of ratio between face and edge color that most surfaces exhibit naturally. So just remember, glancing angle is what you see in your peripheral vision. It's really not something you look at directly, yes?
So if the Fresnel exponent is really, really high, that means that I'm only going to see that reflection at the very edge of my object, right? When the angle is nearly 90. But if it's very low, that means that I'm going to see that reflection closer.
Well, we're going to break it down when we actually put a material on an object, and you'll be able to see how that exponent works.
Okay.
It basically just says, you know, if I've got, say I've got an object, and this is a weird example, but say I have an object that has no reflectivity when you look at it directly, but on the edges it's like a mirror. Well, how far does that mirror effect stay until it stops being a mirror and becomes completely diffuse? That ratio, or that distance, is going to be your exponent.
Right.
It's like a interpolation, a gradient between the two. Make sense?
Yes.
Okay. Anybody else? That's why I like you guys. I have a scene for you I like to play. It's got 2 objects, very simple, but one of the objects is self-reflecting, and it causes issues unless you know how to take care of them. All right, so physical mode. Physical mode, we have what's called an edge color. This operates kind of like the multiplier. This gives you the amount of reflectivity in physical mode. It doesn't function exactly like edge color does in artistic. All the reflectivity is measured accurately using the next 2 attributes: refractive index and extinction coefficient. These are based on scientific measurement principles. So, let's take that and make some sense out of what I just said. If you go into 5.1 practice under reading and click on the refractive index database, that should take you to a website that I bookmarked for you that shows you what the refractive index and extinction coefficient are for most common objects that we're used to. Now, this is meant to function like a library. So the shelf is going to be the category that you want to go to. The book is going to be the specific material, and then the page is going to be what is the recipe for that material. So for example, say I want to choose, I've got main simple organic materials. If I go to the book, I can see I've got silver, I've got aluminum or aluminium, argon, gold, a whole bunch of stuff. So if I go to aluminum, it's going to give me a page. And there's a whole lot of different, oh, you can't even see it on this. So I'm going to go under the assumption you're either following along with me or you've got Go to Training open where you can actually see what my screen looks like. But it's got different formulas or different measurements for aluminum, from different years, different laboratories, different people, different organizations taking those measurements. They're roughly going to be about the same. The ones that they have by default are the most commonly used ones.
Which ones are you gonna help me? Or we gonna use each other?
Well, that's going to be up to you to decide which one matches your reference. Because everything's going to be based off of reference. If you're trying to make something based on what you remember, memory is faulty at best.
No, but what I mean is saying, what I mean is saying in terms of like the page, so these are different scientists and that's like the board that people discussing differently.
Page, I would go with what the standard models in simulation are. You can try the experimental stuff. Depends on the year. You can see now, for aluminum, aluminium, I chose experimental Matthewson and Myers, right? They've measured the refractive index to be 1.2046 and the extinction coefficient to be 6.8949. If I change that back to like a standard model, and I have to wait for it to go back till it loads the data in, because I guess everybody's using this all together. What's that? Yeah, the internet's slow. All right, well, I'm going to come back to that. Hopefully when the internet catches up or the Wi-Fi signal is not bombarded. Because remember, I'm busy trying to stream, go to training to you guys at the same time. We're all trying to access it. So it is going to take a while. All right, you saw the two numbers I had there. So the index of refraction or the refraction index number gets plugged in here. The extinction coefficient gets plugged in here. So they are basically describing dielectric reflectivity on a material. The extinction coefficient is a second refractive index. It's kind of like a multiplier. And those two numbers together make the material, and by material I mean the Pixar surface, behave like aluminum would if you actually had aluminum and put light on it. It's going to reflect or try to reflect exactly the same way. All right, roughness in either physical or artistic is the same. By default, Pixar surface level of roughness is 0.2. That's roughly 20% rough. How do I know? Well, most of these sliders are 0 to 1. So 0 being off, no roughness at all. 1 being totally rough, it's diffuse. All right, first, before we go any further, any questions? Right, so anisotropy We're going to talk about why things are anisotropic. The difference between just a regular roughness coat on a material and something like brushed metal is the fact that brushed metal has organized roughness on it, as opposed to just random roughness. So if I use the back of my phone as an example, right, you can see areas that have been really scratched. That is not organized. That is just in all different directions. Now, the thing about anisotropic materials, remember I said that most reflections are what we call isotropic. That means no matter how you rotate the surface of the object, for example, my phone, you can hold up your phone to get a highlight in it from one of the lights in the room and rotate it. Does it change the shape of the light at all?
No.
Nope. It's still basically going to be round. The difference is when I hold up my thermos, what happens to my nice round highlight?
It's distorted because of the surface of the thermos, because of, yeah.
Yep, it's distorted. It stretches. It is vertical. That's because my roughness on this is horizontal. The thing about an anisotropic material is that the distortion or the roughness always makes the highlight stretch perpendicular to the direction of the roughness. So if the roughness is horizontal, it's going to stretch vertically. If I rotate my bottle, the highlight changed. Now my roughness goes in what direction? Now, roughness is now vertical. Because the highlight stretched side to side, it's always going to be perpendicular to the roughness, or 90 degrees. That's why this is an anisotropic reflection. So Pixar surface has an easy fix for that. Underneath the advanced section in the primary specular, we've got anisotropy. If you turn it, the default is 0, which means the effect is off. If you turn it to 1, it's going to stretch the highlight vertically. If you change it to -1, it's going to stretch it horizontally. Now, just using anisotropy is not going to give you the total result. You also need to have roughness. So the roughness default of 0.2 is probably not enough. You need to increase it. So it stretches the highlight like it should. Right. BXDF, like I said, the X we're replacing with R. The X could also be transmission. It could be S for subsurface scattering. It could be anything we're measuring in two directions. How the material responds to light. Like I said, we're using BRDF right now. Okay, so again, just a recap. In physical mode, we're using edge color, or we're using face color. No, I'm sorry. Physical mode, we're using edge color, refraction index, and extinction coefficient. In artistic mode, we're using 0 degree, or we're using face color, 90 degree edge color to adjust it. Now, the thing is, you would think, okay, I can adjust my 0 degree, 90 degree, I can get metal doing that. The problem is, it's not going to give you the exact look of metal, because you're never going to be able to dial in how that extinction coefficient and refraction index interact with each other just using 0 degree and 90 degree. That's why for Anything other than metal, we use artistic because that stuff is easy to dial in. Now, in addition to having primary specular, physical mode, artistic mode, anisotropic, down under the advanced section, right here, there's something called the specular model. And by default, the specular model is going to be Beckman. There's also what we call GGX there. What's the difference between the two? They're almost identical, except GGX is slightly softer in appearance for reflections. So consequently, for something like brushed metal, maybe GGX gives you that little bit of extra softness you want because brushed metal, first off, is very rough. The reflections are going to be blurry. And again, just a little bit extra softness there. Highlights a little sharper with the Beckman. Both work well. If you choose not to do it, you could probably get similar results by just dialing down maybe a little more roughness. Like I said, Project 5, the Pixar surface is going to take you to RenderMan's help, or not really help docs. They're all their documentation. The Pixar surface, it goes through every single module in Pixar surface. It's gold. And then the refractive index, once we get any internet back here yet? Let's see. I guess we have to sacrifice something to the internet gods. The internet's not happy. We have taken the internet for granted.
I believe it. It's the end times, everyone. The internet is going offline.
The internet is angry with us. It is demanding a sacrifice.
I nominate David.
If we're out in it for a week, we are going to need a poke apocalypse.
Your vitality is more important than mine.
It's only 5 minutes and we're there already.
Yeah, traffic, that was basically what it was in New Jersey after Hurricane Sandy.
Well, I'll bet.
Even got to the point like where my dad and I were saying, it's like, when you go to bed, you make sure you have something like by your bed with you. But by heating all that, you need like have like a small knife or something with you just in case if we get pumped. Because people were driving around scouting the areas.
Oh, nice.
We were like, this used to be a nice little town. And then right when we got the power back, everything was fine.
Of course.
It was really fun.
All right. So, in addition to adjusting the material, we also need to worry a little bit about what's going on in the render settings. So, under Integrator, in the render settings, under our path tracer, you want to make sure your max path length is up to 10. Some of the projects you may have dialed it down to get a little quicker render. I think some of the environments may have had 2 on by default, but the default is actually 10. You want to have that so that we can measure how objects reflect back and forth to each other. Just think of mirror in front of a mirror. You hold a mirror in front of a mirror, what do you get? Infinite mirrors until you can't see anymore. In CG, we don't get that for free. We got to count all those different reflections before it becomes not visible to us. 10 is a good number to start with. That's why they chose to have that as the default. Make sure that's on. All right, so.
So it needs to, the integrator needs to be set to path trace, and the max should be 10, right?
Yep, path tracer, just like always, max path length should be 10.
All right,
If it's not,
all right.
especially for the environments. All right, so what I'm going to do is set my project to the Lecture5 demo. And you just want to open up the helix sphere RM. It's an MA file. If you've set your project, open the scene up correctly, you should have a dome light in there with an image in it. You should have also a distant light in there already. Now, a couple of things that we're going to do once you get it open. First, check your dome light. Select it, go in, make sure that your image is visible in the dome light attributes. If you can't see it, relink it. There you are, you sneaky devil. Right there. Because you'll go to render and it'll either show up white or it'll show up black. Right. Each object has what assigned to it?
Lambert.
Lambert. So we're going to assign a separate Lambert to the ground by itself, or not a Lambert, separate Pixar surface. So PXR surface on the ground. I'm just going to label it ground. And then helix, which is that coil right here, and the sphere, just shift select both of them and assign another Pixar surface to them. Shift T, not Command T. So the ground plane has its own Pixar surface. The helix and the sphere have a separate one. Check your render settings. Also check the renderer. Make sure that it is actually RenderMan.
Just typing.
Hacker man. Hacker man.
Maximum number of people that can be unmuted at once.
Kick them all out. Fail them all for
I
attendance.
think there's something wrong with the connection though,
Oh, I'm sure there is.
because I actually can't get back in.
This generally doesn't happen all that much. Not unless there's a crappy connection and it keeps breaking.
Welcome to this room.
All right, so first off, make sure you've got RenderMan set up as your renderer. I'm going to make sure my integrator is set up correctly. Max path length at 10. IPR samples, I've got them dropped down to 32. And I'm just going to render out from the perspective. There is no render cam.
What does the staff need to do for the image not like turn out white on the background?
Did you go into the attributes in the
Oh, I think it's.
dome light and make sure it was loaded in there? Yeah, because if you go into the attributes in the dome light and don't see the picture icon in there, that means you need to relink the image up, which is what I had to do also.
The value is 50%.
Yep, no, everything's default.
Oh, keep it default?
Yep, I left everything default. Yep, the default is 0.18.
So this isn't my, for mine it says that my file is linked with the Zen bar and it's just not showing the actual image, so then
You need to relink it.
Okay.
If you don't relink it, it'll either show up black or it won't show up It'll show up white.
Okay.
Just remember, click on the dome light, go into the attributes. You probably won't see the image in there. If you don't see the image, you need to click and relink the path to it, which once you click on it, it should take you into your folder structure, go into source images, find the Zen Garden, click on it. It should be there when you re-render it. Worked? Good. It should show up. All right, so we're rendering from perspective. Now, at this point, you can select either the helix or the sphere. They both have the same material on them. We're going to go into the Pixar surface and start playing around with the material. So, I'm going to kick off another IPR just to let it go. Now, down under primary specular, we're going to leave diffuse alone for now. Primary specular should be an artistic. Take the edge color and turn it all the way up to 1. When you do that, tell me what you see. Yep. Go down into primary specular, take your edge color, turn it all the way up to 1.
Yeah, I see a little like a little piece of edge.
Yep. Almost like a rim light on the edge. And basically nothing in the center. That's all diffuse. Right under diffuse. They should, because they're the same material. All right, so notice that the Fresnel exponent at 5 gives you what most people consider to be an average level of reflectivity on just the edge. Notice that it falls off fairly quickly when it gets around towards the front. If you increase the Fresnel exponent, you're basically closing off that edge so that it gets smaller and smaller, and by the time you turn it up to like 10, it's almost non-existent. There might be a couple of pixels around the edge that are visible, that are reflective, but if you go up any higher, you're just going to choke it off.
You said it's under diffuse, right?
Primary specular, right under diffuse.
Oh, there it is.
So, the Fresnel exponent at 5, try turning it down. Now you're taking that 90-degree reflectivity and kind of pushing it towards the center a little more. All right, who's having trouble? You're having trouble. How?
I just can't access my control surface tab. Even though I'm trying to control surface to my objects, I just can't access the tab.
Then you have to like
Anybody else? Yes. What's the problem?
Also noticed that I was messing with the wall. Because I know I was oh, this is gonna be my base, but then I started messing with the wood because it's my base. I'm not supposed to like this. Yeah, okay. Is it a 5? The 5 is default, right? 5 is the default. You check your ID. Stop IPR. Select the drum line, go back. Alright, so you're having a problem where everything is white. Really up there, that's the same problem that's part of that whole permission issue.
Anybody having a white background when you render? It's probably a permissions thing. Try taking the whole project folder, putting it on your desktop, relinking it up, and it should work. Yeah.
I found that if you just re-upload the Zen garden to the dome light, it'll fix that. It'll fix it. Oh,
No, it turns white. He's got a permissions thing. He had that problem before. Yeah. Okay. So, what we did was turn up the edge color all the way, rendered it out in IPR, and then we were just kind of messing around by taking the Fresnel exponent, taking it up to 10. You can see that it almost chokes off the reflectivity on the edge. You take it down to 0 and it makes it almost like it's chrome. Well, here's the difference in the face color. Let's turn off the edge color and turn your face color all the way up. Now with your face color cranked all the way up, it's going to look like it's a mirror, except for the very edges, which are going to be flat looking. Right here on the edges. Now, with the face color all the way up, you can see how roughness works. Take roughness, turn it down to 0, and you basically have really nice, sharp looking reflections. Here's the thing though. This is not truly a pure mirror. This is mostly reflectivity, but we are getting a little bit of diffuse bleeding into the color here. How do I know? Watch what happens when I turn it off. I turn off the diffuse gain to 0. Now it is basically a mirror. Yeah, which is just way too perfect.
Yeah.
So with the gain turned up, I'm getting some of that gray bleeding into my reflection color. Most objects have some level of the reflective base or the base material showing up. Does that make sense? Now, most average objects do not have this level of reflectivity. Right, so here's kind of my recipe for an easy start with materials. For everything that's not metal, first thing you want to do is, if it's got any reflectivity other than a carpet or fabric, something that's totally diffuse. If it's not that, if it has some reflectivity, first thing I do is come in, I turn up my edge color, and then I turn up face color to the degree that it needs reflectivity. So for example, the back of my mouse, let's use that as a guide.
So, edge color will always come out of it?
I would say 99% of the time for most objects, yes, if it's not totally diffuse. Because most objects exhibit a high degree of reflectivity around the edges. Now, if you do it and it's way, way too much, so for example, this is really pretty rough, this pod. It's got a lot of reflectivity on the edges. If I find that there's too much on the edge, then I'll pick the edge color down just a little, but to match my reference. Most of the time I start with it all the way up all the time. Now, like I said, the default level of roughness is 0.2. That default level of roughness is a good starting point, let's say. So here's what we're going to do. It's going to kind of be our challenge. We're going to see if we can recreate the 3 levels of reflectivity that we have from the mouse that I have here. So first off, what color is the back of my mouse?
Black.
Is it black? Dark? Is it Vanta black?
No.
All right, so no. Then it's dark gray. So first thing I want to do, my base color comes from where? Base color comes from diffuse. So my base color gets turned down quite a bit. So I still got a little bit left in there. It's not quite. And I'm going to turn up my face color just a little here. Now, here's the thing. Let's take a look at how rough is this. So, what I need to do is turn my roughness level down. So, how do you know how far to go? You could turn it off. I usually like to go down to 0.1 and see what it looks like. Shut up. Stop doing that. All right, so yes, I realize different environment, different reflections, but I still have color in here. How's my level of roughness compare? Yep, I still looks just a little blurry compared to what my reference is. So, just like everything else, I knock it in half. So, half of 0.1, 0.05. I like to be methodical about this, because if I just mess with the slider, it doesn't tell me what I'm looking at. I'm just grabbing numbers. All right, so maybe a little more reflective. Maybe my reflections are a little dim. For me, that's the amount of face color. Now, trouble is, if I turn up my face color all the way, then I've got a mirror. So I really have to be careful how much reflectivity I let in.
Is there no way to input a numerical value for the face color?
Yeah, you can click on it and go down and look at the value.
Oh, right.
So, face color, edge color, all we're really doing is changing value. And our value goes from 0, which is black, to 1, which is white. They provided a nice little slider because it's an easy interface. It's called scalar numbers, 0 to 1. So, this is fun. Not really, not a whole lot. All right, so like every 3 seconds, we're losing the connection and restoring it, so it's a miracle. right, so if I look at the bright parts where my monitor is reflecting in my mouse, I'm getting roughly the same level, maybe a little more reflectivity. Knock the roughness down just a little bit more. I want to see a little more clarity in some of my reflections here. Right, so for this, edge color all the way up, which means it's 1 or white. The color itself is coming primarily from the diffuse, so it's really, really dark gray. And then it's just a matter of adjusting how much face color. The more face color, or the higher you increase it, it's going to be more reflective. Meaning we're going to lose a little bit of the black from the diffuse. Now, the only other thing once you get those two is to figure out how rough it is. How rough is going to be whether your reflections are blurry or not.
Around the edges is when you clear, it just seems like all the reflected is really the highlight.
You mean here? Or are you talking about here?
I'm talking about like in the center of the mouth.
Right here? Yeah. That's because, remember, it's also spherical too, so it's going to show more on the edges than it is in the center. It's all about that 0 degree, 90 degree. It's always going to be more reflective towards the edges. So yeah, when we get closer to the edges, it's going to be more reflective than in the center. And also, this is showing the ceiling, which beyond my light, there's no lights in the ceiling. So that's why it looks like a black void up there.
Also, because the highlight is a really strong point that people have at the so.
Right, and like I said, there's nothing in the ceiling.
Yeah.
So,
I feel like it's one,
Is there also a slide on that some sort of limit that we need to know for how far does it reflect, or does it reflect as far as we can
what does the reference show you?
see? Okay.
Now, had I built an environment like my desk, then we would be trying to get it exactly. But we're just trying to get a feel for color, level of reflectivity, and roughness. Those are your three primary things. What's the color of my object? How reflective is it? How rough is it? And after that, it's all fine-tuning. And when you first start, edge color all the way up. All right, so I'm going to stop my IPR. And now I'm going to switch over to the second reference, which is going to be that. So what color do we have here?
dark gray, lighter gray than the
Lighter gray. All right, so that should be a little bit easier. Let's go with that. So I'm going to try and go by the color swatch here, or you know what? I could just go for broke and re-render again. Close. So now, before I adjust the amount of reflectivity, I'm going to adjust the roughness. So do I need less or more?
More.
Yeah, definitely. So I'm going to start at the default of 0.2. Is that rough enough? So you can see with each tenth of a point, it's going to increase it quite a bit. Now I can still see a little bit of edge colors on the side here. Maybe I need to bump up my face color just a little bit. And I do mean just a little bit, just a little touch. Now, rough enough? Nah. Let's go 0.4. Change one thing at a time, just like when you're lighting. Change one angle. Don't try to change too much. All right, so it's what I'm looking for when I look at this reflection here is I can see it's still pretty tight here. and it's definitely blurry on the edges, but it's not completely roughed out like this is. So, definitely in the running. Let's try 0.5. 0.5, might be a little much because we're kind of losing the focus here in the middle. So maybe we split the difference like you suggested. We could try 0.45. I think it retains a little bit more of that center and fuzzes out the edge. All right, as far as color goes, well, I'm talking about the actual gray part. Yeah, it looks like it could be, and that's under diffuse. Now, as you suggested, maybe bump up the face just a little bit more so I can get this level. I can still see some more detail here. So I don't want to bump it up a whole lot. That might be a little too much. All right, so again, color of object, that's your diffuse color. Amount of reflectivity, that's your face color, and then roughness. How blurry are your reflections? Like I said, if you keep the 90-degree or the edge color all the way up, most of the time you're going to nail it. Like I said, on the edges, maybe you dial it back a little. So I'm looking here on the edges. It's roughly about the same amount of reflectivity. Don't forget, when you add roughness, it will affect the edges also. So keeping your edges all the way up is going to help. Yes?
Do these objects like mirror like light? If I were to like grab an object and just beam a ray of light, and then would that project into another object, or is it something else?
No, it's going to project into another object. We're going to get into that when we get into metals.
Okay.
So I like to keep that total reflectivity part, unless it's a mirror, which what I showed you how to make. We're going to be doing metal, and metal's going to be where you see reflections in reflections in reflections.
Because if I put a metal on the table, if it's a ball, I put a metal on the table and I shine a light on it. Some of that light is going to bounce off the metal. It's going to land on the table. And you're going to see.
Yep. Same thing here. It's going to bounce off the table. It's going to hit the object. It's going to bounce off that object, hit another object. That's what your max path length is for.
So the higher I set it, the more, you know.
Right, but at 10, that's what Pixar recommends. That's most
Yeah.
of what you need. Any higher than that, remember what happens to your render time. It's going to go up, yes. Now, when we start adding materials, you guys are going to start looking for reference today. You're going to start assigning materials into your scenes. Your render times are going to go up because each object is going to have a different material. Some objects, like my thermos bottle here, this has at least 3 different kinds of materials. It's got the body, which is brushed metal, it's got a plastic cap, and it's got a different colored plastic cap on the top. So there's 3 materials here just for this.
This is why we model everything on parts.
Exactly. Model everything in parts. You try and model the edges as close as you can to the real world object, because now reflectivity makes a difference on your edge quality. Without good edge quality, you're going to have like just razor sharp edges and nothing's going to look natural. Everything's got a little bevel to it. All right, so I'm going to stop this. I did already. All right, so this is the back of my mouse. That's the buttons. Let's see if we can do the rubber on the sides. So that's going to be this. Color. All right, so the base color is going to be diffuse. That's going to be pretty dark. All right, so I don't want total. Let's try that. I don't want total black. All right, so how about level of reflectivity? Barely any? Yeah, I'll kind of go with that. There's some there, but definitely a lot lower than the top of the mouse. How about roughness? Yeah, a lot rougher than this. This has still got too much focus in the spec highlight. So this, I'm going to start at 0.5 and work my way up. Yeah, it looks like it. How about the level of reflectivity? That's going to be how dominant is that highlight compared to my reference. All right, so here, if I take a look at the helix also, I mean, that kind of looks rubbery. That's kind of what we're after. All right. So let's take a look. Let's reevaluate these. So here's the back plastic. A couple different surface shapes. There's the button. And there's the rubber. Does that make sense? Questions? So, if you can do these three objects, you could pretty much make anything that's not metal. It's just going to be color, level of reflectivity, and roughness. Now, for Project 5, we are not doing texturing. So, you guys are going to look for reference. So, for example, suppose you say, okay, I like this pattern on the floor. Why? I'm just using this as an example. It's disgusting and ugly. But, just say, for example, you wanted to use this. Now, how do you know what to choose for the base color? You're going to choose the average. What is the most dominant color or value that you see there? You're going to sample that, use that as your color. Reflectivity? No. It's pretty much diffuse. You're done.
Would it help to grayscale it? Or
No. No.
Because you want to keep the color.
You want color.
Okay.
This practice, this whole exercise is all about color and reflectivity for now. We'll get into glass on Tuesday. Yes?
I was going to ask if does the diffuse color affect, for example, if I were to texture in a UV map and I put like a texture on it, does the color affect the texture at all? Like,
If you put a map, the key word there is map.
mm,
If you map something to it, you have to have UVs.
okay.
Because you're going to say this pixel that has this color has to go here, where this UV is. This pixel that's a different color has to go over here. And if you don't have your UVs laid out, they're not going to lay out in the same place.
Right.
Right? For color, solid base color, you don't have to worry about UVs yet. Yet.
Yeah.
Right, so if you want to do the wall, our wall to the right here, your left or your right, it's the same wall. What color?
Yellow.
Yellowish? All right, level of reflectivity.
very low?
Barely any. How about roughness?
Yes.
Pretty rough, yep. So for this, even though you don't see much of an edge, still put the edge color up to 1. Dial in the amount of reflectivity and the amount of roughness for it. So that'd be what you sample. Desktop. It's got a texture. How do I know? Because if you look at it closely, there's more than one color. What would you sample? What would be your base color? Just to be a stand-in for this desktop.
really light.
White, brown, beige, whatever you want to call it. Yeah, that's your color. You sample that, adjust your reflectivity, adjust your roughness. Now these we tend to see at more of an angle than 0, right? Because they are usually perpendicular to us when we're looking. If you have something on this, like this in your scene, for example, the interior, you've got that coffee table in the front. You're going to see more edge reflection than you are face reflection. So you're going to be adjusting the amount of reflectivity based on what you see. So remember, edge color is always going to be up all the way. Face color, you're going to adjust it till you get the result that you see in your reference. Does that make sense? So it's all about color, amount of reflectivity, amount of roughness. If you can nail those down, you can pretty much do everything that's not metal. Questions? Now, it's a good time to take a break. When we come back, then we're going to deal with metal. Only because it's cool and you get to play around, hopefully, with the database working. What I'll do when you guys go on break is, hopefully nobody else will be on internet, I'll jump in and see if I can't get a couple of screenshots in case the internet's not working. At least we can use some examples of how to use the database. Because it's a great database when it works. Or it's not its fault, it's the internet's fault. All right, so good time to take a break. So come back at 3:30.
Well, I mean, we could actually split it. We could put it in, just go to the database and write down some of the coefficients for metals and.
Yeah, but first you got to get to the database.
Yeah. I wrote down like a couple of coefficients.
All right, so 3:30, come back.